Hello from the office of the Able Homestead. Again, apologized for the absence. However, Liam was born last Wednesday morning at about 7:11 a.m. Um, my wife is doing great. Liam's doing great. Appreciate you guys thinking about us. It was a long process. We started the labor process at 5:30 on Tuesday morning, and then he did not come until about almost 26 hours later. So made for a long couple of days, but we have recuperated a fall break. So I'm actually recording this Sunday night. So if you hear the thunder outside, of course I waited until the storm decided to come. So hopefully power doesn't go out, and I can finish this video before anything funky happens. So here's the deal. I've decided after looking over some things, first couple of days, I'm going to record this one video to cover several topics. So this video may be a little more lengthy. And then there's going to be one assignment on Oasis today. However, I'm going to give you a couple of days to do it, and then you guys work on it. Take the 2 or 3 days in class to work on it. Make sure you understand it. Email me with any questions. If there are questions that I get from a large group of people that don't understand the same concept, I will record a subsequent video, put it on Oasis that day, so that everybody is on the same page, and we can make sure we understand the concepts and that kind of stuff. But if I don't get any emails from you, I'm going to assume that you know and understand this stuff, and we'll be good to go as far as that goes. If I only have like 1 or 2 questions, I'll answer them on email instead of recording a whole new video. But there are, I think there's 23 questions that I have on the homework assignment. Should take most of you should only take 2 days, but I'll go ahead and give you 3 days just to make sure that you know and understand how to do it. It's going to be 1 through 26 on the link that I give you. It's from the virtual textbook. Make sure you're only doing problems that are below the evaluate, red homework and practice banner. The problems that are above that are just like sample problems that we don't really need to do. Now, if you want to read through the textbook to get a little more understanding, if you like to read the examples and see the example problems, you can scroll up on that link that is in Oasis for your homework assignment, and it will actually walk you through step by step some of the similar types of problems and that kind of stuff. However, hopefully I'll address most of those things here on this video, so that you won't need to do that. And I'll just kind of work similar problems that are on the homework here for you, except for the word problems. I'll let you try to wrestle with those, and then whenever I come back, or maybe Thursday or Friday, I'll record another video explaining the word problems, because I'm sure that'll be a little bit different. But first several problems on the homework today. We're solving quadratic equations, or it's also known as finding the roots, or finding the zeros. We've already done that with our functions, where all the root is or the zero is simply finding where the graph crosses the x-axis, or what value for x can we substitute in there that makes my equation equal to 0. That's why they're known as zeros, is because it makes my whole equation equal to 0. So that's what we're doing with all of these things on the next couple of days. Now, there are 3 different methods that I want to show you how we can solve these equations, how we can find the roots, how we can find the zeros. That's all different terms to say the same thing. Finding a zero, finding a root, finding the solution are all the same thing. A root is the same as a zero, is the same as a solution for a quadratic equation. So don't get confused if I use one term at a certain point and another term at another point. It's all the same thing. It's just the answers to the equations. We're solving these quadratic equations. Now, remember we talked about this a little bit earlier when we were talking about functions. Whenever I have x raised to a power, I can have as many solutions as the highest power x goes to. Now, of course, quadratic equations are x to the second power x squared, so that means all of these problems are going to have 2 solutions, okay? And you'll see that over and over and over again, okay? It may be one number, but it may be a positive and a negative value. We'll look at that, okay? So first things first, if I have an equation that is like x squared minus 4 equals 0, something like this, there are three ways that I can actually solve this equation. The first way is probably the simplest way, especially for problems like this, where if I just have a quadratic term and a number, wherever it is right there, I could solve this by what is called the square root method. And basically all that means is the same way you've always solved an equation. Okay, you want to get the x by itself, move everything else over to the other side of the equation, and then I'm going to take the square root of both sides because I don't care what x squared equals. I want to know what x can equal. Okay, so very simple. I have x squared, and then I have a negative 4, so I want to get the x squared by itself. In order to do that, I simply move the negative 4 to the other side by adding 4. And if I add 4 to one side, again, I have to do it to both sides. So I add 4 to both sides, and I get x squared equals 4. Now, I know most of you right now are yelling out in the classroom or in your head or whatever, the answer is 2. Well, you're only half right, okay? Because for every quadratic equation, I have 2 solutions, okay? So mathematically, algebraically, how do I solve this? How do I get rid of an x squared? I have to take the square root of both sides. Now, when I do that, I have to take into consideration something that I know about square roots, okay? There are 2 different values for this 2 that actually make this equation work. I know 2 works because 2 squared is 4. However, I also have to take into consideration what a negative times a negative is. And as you know, a negative times a negative is always going to be a positive. So, in order to do this, anytime, easy peasy, okay? Anytime I take the square root of both sides of the equation, I have to take into consideration both the positive and the negative values that make that solution true. And this is how I write it. This is just called plus or minus. I just write plus and minus over each other, and it's always written like this. So this is the solution. These are the 2 values that make this equation right here work. Because if I do 2 squared, that gives me 4, and 4 minus 4 is 0. But also, negative 2 squared, negative 2 times negative 2, is also 4, and 4 minus 4 still equals 0. So that's why when we take the square root and use the square root method, we always have to take into consideration both values of both the positive and the negative 2. So, rule of thumb, in these quadratic equations, when I'm using the square root method, I will always, always, always have 2 solutions, a positive one and a negative one whenever I take the square root of both sides. Okay? Pretty straightforward. Now, graphing method. Hold on, I forgot to grab my eraser. The graphing method. I can't really show you because I only brought my calculator home and I didn't bring a calculator for you guys home, but we've already done this. So all you have to do for the graphing portion, because on your homework it says solve by graphing, solve by factoring, solve by taking the square roots. I already showed you how to take the square roots. Solving by graphing is really, really simple. You already know how to do it. You simply set the equation equal to 0. So if I have an equation that is something like, well, let's just say I had x squared equals 4, the same problem I just had. Now, I can't graph this because in the calculator, there is no way to say 4 equals x squared, okay? I have y1 in my calculator. So the most difficult part of actually graphing these equations is you have to make sure they're equal to 0. Because remember, on the calculator, we're going to find the zeros. If my equation that I'm looking for, if my quadratic is not set equal to 0, I'm not finding the zeros. This will be finding the 4. There is no button on your calculator where you can find the 4 of a graph on your calculator. But there is the zeros. Okay, so what I have to do is I have to manipulate this equation to make it equal to 0. So I just throw everything on the side of my quadratic term. So just like kind of in reverse of what I did with the square root method, I would subtract this 4 from both sides and get x squared minus 4 equals 0. Pretty simple. Now I have an equation equals 0. Now to solve this by graphing, all I do is enter y1 equals x squared minus 4. Okay, you can enter that into your calculator. It'll pull up a little graph. Remember, if it's zoomed to something funky, you can hit zoom 6 to get you a regular window. If you keep getting an error, chances are your calculator's stat plots are on. So you hit, I believe it's second y equals, and you can turn off all of the stat plots. Because remember, we did those regressions in last unit, and so some of the calculators may still have some of the stat plots on, some of the regression equations in there. So clear it out, set your equation equal to 0, enter whatever the other side opposite of the 0 is for your equation, and then find the zeros by hitting second trace, zeros, and then doing the left bound, right bound. Remember, you go to the left of it, you go to the right of it, and then you take your guess. And remember, the zeros are where the graph crosses the x-axis. So the solutions are going to be the two places where this equation crosses the x-axis. Now, if you were to graph this one as an example, you're going to see that the graph crosses at both -2 and +2. So those would be your two solutions. Your two zeros would be x equals -2 and x equals +2. Same answer that I got when I was taking the square root, plus or minus 2. Okay, all of these problems, the first couple of problems, I think number 1 and number 2, are going to have the same exact answer. Okay, you're just using different methods in order to find the same answer. Okay, for this problem, it's always going to be x equals 2 and x equals -2. Okay, now, last way, it asks you to solve by factoring. Okay, and then all we have to do, we did factoring practice last week, so hopefully you didn't lose all of that over fall break. But all we have to do is do the X box for this equation. So again, to solve by factoring, I again have to set it equal to 0. So it's not equal to 0. I have to make it equal to 0. And then I simply factor. Okay? And that's using the X box. So remember, with this one, I'm going to find what two numbers multiply to give me -4 and add together to give me 0. Right? And then my box is going to be x squared in the top left, -4 in the top right. Okay? And again, we've already cheated because we've already solved this problem twice now. I know that the two numbers that multiply together to give me -4 and add together to give me 0. And the reason it's 0 in this one is because I don't have a middle term. Okay? And that would be 0x. Okay? So 0x means I don't have an x term in there. That's why the x looks like this. And the two numbers that multiply together to give me -2, to give me -4 and add together to give me 0 would be -2 and 2. So I have -2x and 2x, like so. And then all I have to do, I have x times x gives me x squared, and I have +2 and -2. So I have x plus 2 times x minus 2 equals 0. So I have the factored version of this quadratic right here, just like we practiced last week. Now, you'll notice one change I did do is I kept the equals 0 because this is an equation. It's not just factoring a polynomial. Okay, so this is important because what I now have is an equation. And what I'm trying to do with this is I want to set each of these two parts equal to 0. The reason for this is really pretty simple. What is 0 times anything? Obviously, it's 0. So if this first term, if I make this one equal to 0, 0 times whatever this is, it's going to be equal to 0. And the same thing, if this second term is equal to 0, it doesn't matter what the first term is. Anything times 0 is 0. So either one of these terms equaling 0 gives me my solution and the whole equation equals to 0. So now what I do, much like the absolute value functions, is I draw little railroad tracks. Because that means I'm going to have two solutions for this. Okay, and I do this to kind of keep my work separate. So I want to set my first term equal to 0. And then I want to set my second term equal to 0. And like I said, I'm only doing this because anytime I have 0 times anything, it equals 0. So if either one of these terms is equal to 0, the whole thing ends up being equal to 0. So I got to know what are the two values that can make this equal to 0, because that's my solutions. And again, that's pretty simple. I'm going to subtract 2 here. I'm going to add 2 here. And my solutions, again, end up being x equals -2 and add 2, x equals 2. So again, my two solutions are -2 and 2. Okay, so that's the three methods for solving quadratic equations. Now, for these problems on your homework, you're going to have to manipulate the equations a little bit. To graph them, you're going to have to get them equal to 0. To factor them, you're going to have to get the equations equal to 0. To solve them by square root, you're going to have to get the x squared by itself and then take the square root of both sides. But that's really all there is to the first several problems. Now, numbers 3 through 6, you're just taking the square root. So again, that's really straightforward. All you do is you get the x squared by itself, and then you take the square root of both sides. Now remember, we talked about this a couple of weeks ago, but I want to refresh your memory. If you have x squared equals a negative number, let's say we end up with, well, let's just do 2x squared equals -6. Now let's do -2x squared equals 16. Let's say we have this problem right here. Okay, I want to get the x squared by itself. So I go ahead and divide both sides by -2, which leaves me with x squared equals -8. Now, I've got my x squared by itself. My next step is to simply take the square root of -8. That leaves me x equals plus or minus the square root of -8. Now, we did this a couple of weeks ago as well. We have to simplify my radicals when I can. Anytime I have the square root of a negative number, I know it can be simplified because I can't do the square root of a negative number, but I can write the imaginary number in its place. Okay, so that means x equals plus or minus I times the square root of 8. Okay, so that's how I write this. However, I'm not done, because I can simplify the square root of 8 a little bit further, because there is a perfect square that divides into 8. What's the only perfect square that divides into 8? That would be 4. Okay, so I simplify the square root of 8 to be the square root of 4 times the square root of 2. Bring down my plus or minus I, and then what's the square root of 4? Of course, it's 2, so I can bring that outside. So my final answer ends up being x equals plus or minus 2I times the square root of 2. Again, I simplified my square root of 4 down here to be 2. When I bring it outside, it comes in front of the 2I, or in front of the I. And again, I have to get into this habit right here. You'll notice when I took the square root, what symbol did I write in front of the square root? Every single time that I take the square root of both sides, I have to include the value of both the positive and the negative being one of the solutions. Now, this is two solutions in one. I have one answer, it's 2I squared root of 2, but I have positive 2I squared root of 2 and negative 2I squared root of 2. So, if you have any of those problems on your homework where you end up having x squared equals a negative number, don't forget you're going to have an imaginary solution. There's going to be an I in your solution. I don't think there's very many of those, but there may be one or two. So I wanted to make sure that you'd seen it so that you weren't completely confused and confuzzled. Now, if you have x squared equals the square, or x squared equals 128, you're going to have to simplify those radicals. Okay, there's going to be 4, maybe 9, maybe 16, 25. Some of those values may simplify out so that you can simplify the radical and get the complete simplified answer. Okay, that gets you 1 through 6. 7 and 8 are you're writing your own word problems. Numbers 9 and 10. It simply gives you the area of a rectangle. It gives you the dimensions of a rectangle. And remember, area is just length times width. So if the length is sorry, my computer locked up on me for a second. If the length is 3x and the width is x, then I'd multiply those things, and that would give me 3x squared. Well, then number 9, it says the area is 45 centimeters, so 3x squared equals 45. And then I can simply divide both sides by 3, take the square root of both sides, and that gives me my solution. Now, be careful with those, because can a length be a negative value? The answer is no. However, it is one of the possible solutions when I take the positive and negative value of the square root. But since I can't take a negative length, I can ignore the plus or minus in that situation because I'm talking about a length, and I can't have a negative centimeter. It's just not a thing. So anytime you have a measurement of time, of length, of space of any kind, you can ignore the negative, the plus or minus sign, because it's always going to be the positive value, never going to be the negative value. So that's those. Numbers 11 through 13, you're just simply simplifying those. It asks you to find the square. So you just square both of each of the values. Okay, so if I have, well, I'll write that down. If I have if it asks me to find the square of 6i, it's not the square root, it's the square. All I'm doing is I am squaring the whole thing. Okay, so what you have to be careful of is I have to square everything inside. So 6 squared is 36. I squared is, remember, well, I is the square root of negative 1, so I squared is going to be negative 1. So the square of 6i is going to be negative 36. Okay, so that's all you're doing for numbers 11, 12, and 13. 14, 15, and 16, all you have to do on those is simply solve them. You don't even have to solve them to find the solutions. It just asks you to determine whether they're going to be imaginary. So you can get down to the last step of the square root method to get x squared equals whatever, and then if it's positive, then it's going to have real solutions. If it's x squared equals a negative number, that means you're going to have imaginary solutions. So those are pretty straightforward. And then 17 through 20 is basically the same thing. You're solving them using the square root method, and then you're allowing for imaginary numbers. So that's where you're going to simplify using, if you have this x squared equals a negative number, you're going to bring out the I, and then simplify the square root to get those. So that's pretty much all I wanted. I've already talked enough. I want to go ahead and let you have some time in class to work on this. Make sure you are listening to the sub. I have not looked to see who the sub is, but please don't have me have any negative reports. Please be only listening to this video on your Chromebooks and not be messing around on anything else, and because I really don't want to have a negative report. I want this to work because I didn't want to be gone for a whole week, but it just kind of was necessary for me to do it. So I will, Liam is actually in the other room, and so I will, if I make a video tomorrow night, I'll see if he's in a better mood and not asleep, so that you can see Liam and he can be introduced to you guys. Otherwise, have a great week. Again, if you have any questions, need some clarification, please don't be afraid to email me. You guys all have my email address, and I will address those if I see them. I will try to address them in a timely manner. If I don't see them, then I will get to them as quickly as I can. And if there are a bunch of the same questions over similar types of problems that we actually did, that I covered on here that you don't understand on the homework, I'll make another video to explain some of the questions that are being asked and that kind of stuff. So have a great week. Miss you guys, and I will see you soon.